now? Okay, so let's see what order we should take the. I will look at the project list on. So, not surprisingly, we will start with AVHD.
Okay, I can say something about it. I'm also one of the co-chair for AVHD, and then if Silvio, you can add if you also want to say something about it. So AVHD project stands for Audio Visual HD, video quality assessment, and so the main focus of the project is to develop the video quality models, pixel-based as well as bitstream-based model. And as I mentioned in my introduction, and at some point in time, we started working together with the Q14, question 14 of SG12 in ITU, and in that project, we developed around overall 32 databases. 16 of them I think were training databases, and the other were validation databases. And there were 10 model categories. It was a competition essentially. So 10 model categories where you have I think 3 parametric model categories. 3 were the regular full reference, no reference, and reduced reference cases, and the other were these hybrid categories where you can have pixel information as well as the bitstream information. And this resulted in standardization of P1204 series of recommendations. So three codecs were tested at that time: H.264, VP9, HEVC. So the video length we are talking about is 8 to 10 second videos, so short video sequences. So resolution all the way up to UHD resolution. Devices we tested TV, we tested PC monitors, mobile phone, and also a couple of tests from the tablet also were there. And so this recommendation is already published. And lastly, we had extended the recommendation with the AV1 codec, because at that time the AV1 codec was not, so it was still in production. And then later when it was available, then we also extended the standard to AV1 codec. And so the updates are available already. I think the only missing is P1204.3, where this extension is still in planning. Other than that, Silvia, if you want to add something, please go ahead.
Thanks. No, that's perfectly fine so far.
And there is also the live QoE project that we had started a couple of meetings ago. This was together with Twitch. And at that time, we wanted to formulate basically video quality modeling for video conferencing applications. That unfortunately could not take off because at some point in time so the contributing parties they were not very active. I don't know the focus chain, but at least we had initial version of this parameters or ranges of parameters that we wanted to test for this project. AVHD also have a subjective testing part. I was not personally involved in that part, and I would leave it to Margaret to say a few words about this part. So subjective testing related activities of AVHD.
Sure. So there haven't been many efforts recently on subjective testing. The most notable one was the effort that VQEG did, culminating in the merging of P910, P911, and P913. And that was organized under, I don't think the calls that we did online were called AVHD, but that's really where it fell into. And that is in pre-approval in the ITU and is all under an improved P910. And I'd also like to note that there's as always, there's a variety of talks that come under this topic of AVHD that you'll see later this week. Thank you.
Now you're muted, Shahid.
Yeah, sorry for that. Yeah, so this more or less sums up the short description of the AVHD. If you have any questions, please you can ask now, or you can also drop me an email later on. I'll be happy to answer your question about AVHD. Yeah.
I'm muted. Sorry. Thank you, Shahid. Just a question there. Is it going to be a Q14 meeting in Stockholm soon related to this?
So there was planned to be a meeting in January about we have a phase 3 of this project, which is essentially focusing on the long-term integration function, essentially integrating the qualities, short video qualities over a longer period. Let's say over a complete video session can be of 1-2 minutes or 5 minutes. And so we had previously in P1203 had a long-term integration function, and that we wanted to update also, and also introduce new features like in case the video quality is so bad, or there are so many interruptions that the user won't terminate the session. So also go in this direction. But that meeting that was planned for other activities also, that is now postponed, and I think the updated schedule is not yet available, but most likely it will happen in February. Martin is more aware of exactly when the new schedule is to come for that meeting. It will be an interim Q14 meeting.
Okay, thank you. Okay, if there isn't anything more about the AVHD, we can move on to the QAH, Quality Assessment for Health Application. Is it Mariam? Are you?
Yes, thank you, Shen. So we are working, we are focused on the quality assessment and visual attention studies for medical contents and all which is related to health application. We are working on, since maybe more than 6 months, we are trying to work on a drafting test to describe how to assess video and image quality for health application. It's how we say, a big work, and it's ongoing slowly, but we have some proposition and some interesting advice during VQEG meetings. This is very interesting for us. For this meeting, we will have a session on Thursday from 2 p.m. CET time. So it will be almost the beginning of the meeting. And we will show you some results from our PhD student, and probably we will ask you to give us some advice and some recommendation maybe for our work. This is almost what I have to say, I think, for today. Feel free to ask me question, to contact us, or to join us if you are interested by our scope. Thank you.
Thank you. Let's move on then to the SUM group.
Hello, Lucianowski. So the SUM group got a meeting tomorrow, starting from, I guess, around 2:50 or something like that. And we've got 2 presentations, and then after break, we've got 5 more presentations. And the 2 presentations that we have is related to tools. So be there before the break if you would like to use our tools developed within SUM and learn how to do it. And then the rest of the presentation is more focused on the results, on specific subjective experiments or specific, let's say, comparison of different, for example, the same scale used in different languages. So an interesting topic. Sorry, I probably should start from general description of the SUM. We are interested in statistical analysis methods. So focusing on how to analyze subjective experiments, but also how to propose new subjective experiments and new methods to conduct subjective experiments in such a way that we have less noise, more robust data, or we understand better what we are measuring, because this is like another problem that we have. Yeah, like maybe we can have very precise measurements, but not really related to what we really are going to do. So if you have any questions, please, I can answer it now, or please join our session. Okay, seeing no question, thank you very much, and see you tomorrow, hopefully.
Thank you, Lucian. Let's move on to the CGI group.
Yeah, that's me. Maybe I can share my screen to give it. Or can I?
Can you share your screen? Or do I have to make your presenter?
I need to, sorry, I need to rejoin Zoom. I think it's a Mac issue. Just give me 1 sec.
Okay. Okay. Maybe we should move to the next. Let's go with Norm, and then we can go with Abhijit afterwards. Oh, he's coming in.
I'm
now.
back. I'm back. If you...
Okay.
Sorry, it's Mac issue, so it doesn't let me share. Let me share my screen. Just 1 sec. I think I can share my. Can you see it now?
Yes.
Okay,
That's fine.
hi everyone. So I'm Nabajit. Like I said, I'm from currently in Sony, and Saman is the chair of this group, the computer generated imagery group, which was formed like I think 5 years back. We are both leading this group. So the main idea behind this group was to focus on analyzing and evaluating computer generated content. So far, it has been focusing primarily on gaming video streaming. So that's something that both me and Saman have been working on. And there are some other groups who have worked on this topic recently. So as part of this group effort, we have 3 work items in ITUT study group 12, which have finished. These are some of the 3 of those work items. I think we have already seen that. You can see these slides later if you want to know more about the details. So these are the 3 currently ongoing efforts. So the one that is the PBVQCG is the one which is working on parametric bit stream based quality assessment of cloud gaming services. So this is a very active effort. We had a presentation.
Sorry, Nabajit. Are you changing the slides, or I just see the first slide?
I am maybe can you I don't see, sorry. Can you see now? I see my sharing screen is.
I think you're sharing the wrong screen actually.
Okay, let me share again, sorry. We don't use, I'm sharing the whole desktop actually. I'm not sure.
Now it looks better, I think.
Okay. So let me restart. Yeah, so the main focus of this group has been devoted towards analyzing and evaluating the quality of computer generated content. We have primarily focused on gaming content, which has been a focus area of both the chairs and a few other research groups. So previous efforts has resulted in creation of 3 work items in ITUT study group 12, G1032 focusing on influence factors on gaming quality of experience, P809, which are the subjective evaluation methods for gaming quality, and G1072, which is an opinion model for gaming applications. Currently, there are 3 ongoing efforts in ITUT study group 12. The first one is a very active effort with many companies and university currently being involved, which is P.BBQCG, which is a parametric bitstream based quality assessment of cloud gaming services. I'm not sure about the current status of the rest 2 work items, but if you are interested in knowing more, please feel free to contact someone who is more actively handling these efforts. Previously, we had a presentation about in the previous meeting in June. We had a presentation about this PBQCG work item, and there will be a follow-up presentation in the next meeting. I think there is a meeting also scheduled in January, which will discuss more about the efforts in this direction. So again, we have been very much interested in identifying topics and members who are interested in topics other than gaming, but we haven't been able to find anyone so far. So our current work idea is to continue research work in this direction, mostly again primarily focusing on gaming quality evaluations, methodologies, data sets and all. And also primarily focusing on the newer approaches, those are like machine learning and deep learning based gaming content quality enhancement. There are no presentations this time, so we had one scheduled for today afternoon, which unfortunately has been cancelled. But we will have some works that will be presented in the new upcoming meeting. So we have some works which we are finalizing currently, and hopefully we will be able to provide an update in the next VQEG meeting. Again, if you are interested in knowing more or joining this effort, please feel free to contact me or someone. These are our email address, and they are also available in the project homepage. Thank you. Any questions? No.
Okay, thank you, Nabajit.
Shall I do the
Yeah.
ETG one next, or do we come back to that later? Or...
Yeah, we can come back to that later. So
Okay.
let's go to Margaret.
Hi, so the no reference metric group, our goal is to develop no reference metrics. And we have in previous years also done work to update existing no reference metrics that are popular. The effort we last worked on, which is in a little bit of a lull, is to come up with an improved complexity metric. So we've been using the SI and TI, which are close to 30 years old at this point, and it's time we tried to develop something that's a little more accurate. So that's the one topic we may see again in the future. And in general, all of the talks will be related to no reference metrics. There's only one scheduled for this meeting. So thank you.
Okay, that was quick. Thank you so much. I think everyone knows the next meet. Follow the what is on the homepage. So, but first, yeah, the implementer's guide for video quality metrics. I think this is joined with JEG Hybrid now, or maybe you take it together somehow. Anyway, please, Enrico.
Yeah, I think I can take them together. As you know, the IGVQM in actually 1 year ago in the VQEG online meeting was decided to move the activities within JEG Hybrid. Actually, we are currently starting to work on this topic, which is basically develop a guideline. At least that was the original idea, to develop a guideline on how to best use the currently available video quality measure, especially objective video quality measure, how to correctly use them, and then many other things that I can discuss later in the introduction of the JEG Hybrid presentation. So at the moment, there's this link that maybe we will soon change into a page, which is already available, by the way, on the VQEG JEG Hybrid website. So, well, presenting both groups together, both projects together, I think I can say a few words about JEG Hybrid. So the original mission of JEG Hybrid was to develop a no-reference hybrid perceptor bitstream model, and this is still reflected in the name. But I must say that in the last few years, the activity evolved into including some other areas of video quality assessment, and especially we focused a lot more on tackling new research questions, hopefully with a long-term impact on the video quality research community. So the activity, we can say, has shifted a little bit over time. And at the moment, there are mainly two lines of activity. There's a strong research interest in modeling single observer's behavior in subjective experiments. And Loic will have 3 presentations in the following JEG Hybrid session that will follow this project's introduction. And we mainly focus on modeling this single observers through artificial intelligence-based approaches, so mainly machine learning-based, deep learning-based approaches, trying to mimic what the observers are doing, developing what we call artificial intelligence-based observers, and then we are trying to also focus on how to best design subjective experiments in order to train this network, which are supposed to model single observers. And the second line of research, which is currently being developed, is indeed the implementer's guide to video quality metrics. I recently sent a call for participation on the VQEG mailing list. I must say at the moment I only got one response. I hope some more will come in the future, especially after this meeting. At the moment, we are basically trying to put together all the data set and all the data that is needed to start this activity. I will say a few words, introductory words about what we are planning to do in the first presentation of the JGAIB session, which is going to follow this group introduction, project introduction when we finish the introduction. I think that's all for the introduction. If you have any questions, of course, you're welcome to ask.
Okay, thank you, Enrico. I think there were no questions. Let's move on then with Cracovia. Please, Nikolai.
Okay, thank you. As I've mentioned before, Cracovia stands for Quality Assessment for Computer Vision Applications. And the mission of the group is to study the visual quality requirements for computer vision methods, because most of the methods for the visual quality assessments nowadays, they are focused on the human judgment of the visual quality. However, what we are interested in this group is to judge the quality in terms of the computer vision applications and the recognition tasks. So responding to this need, we have like 3 goals in the group. The first is to test methodologies and frameworks to identify the limits of the computer vision methods with respect to the visual quality. Then the second is to establish some minimum quality requirements and to establish some objective quality metrics to estimate the visual content if it is used by the computer vision operations. And finally, it's to deliver some implementable algorithms to demonstrate the objective video quality assessment for recognition tasks and for computer vision. As I mentioned before, we have a session on Wednesday. This is the first session on Wednesday. And we have 3 presentations there. There will be a very short one that will be given by me, myself, and Jing Wen. And this one is going to discuss a database with ground truth coordinates for automatic license plate recognition. Then we are going to have the second presentation. It's going to be provided by, I don't know if I'm pronouncing the name correctly, Hanen Brachemi. And this is about the evaluation of the vulnerability of deep learning-based image quality assessment methods to adversarial attacks. And the last presentation is going to be given by Alban Marie. This is going to be a quite long presentation. Alban is the PhD student of one of our culture. Actually, I forgot to mention the cultures. The cultures besides me is Patrick Lecalette and Lu Zhang. So Alban is one of the PhD students of Lu, and his presentation is going to explain the exploration of lossy image coding trade-off between the machine perception and human-based quality impression. It's going to be quite long presentation because, as far as I understand, this is like the whole his PhD thesis being presented at Cracovia, so expect a long one. Okay, so basically this is like everything. So see you on Wednesday. Thank you.
Thank you, Nikolai. Then I see Pablo got ready to present 5G KPI. So please, Pablo.
Thanks, Shell. Yeah, so 5G KPI stands for 5G key performance indicator, and 5G is the 5th generation of mobile communication technology. And I'm sharing this group together with and basically what we target in this group is kind of closing a bit the gap between what we typically do at VQEG, more at the QoE, quality of experience, and like user experience application level, and what is mostly done at kind of 3PP and alike, which is more about network quality of service and so on. And we're trying to understand the influence between both sides of the picture, let's say, especially regarding mobile communications, so video in mobility use cases, and a topic which is key for 3PP, which is industrial use cases. So use cases which are not purely entertainment or video conferencing, basically. We have a session on Wednesday, just after Cracovia session. And yeah, we only have one presentation. It's basically an open discussion, so I invite anyone interested in the topic to attend and contribute. The idea is basically describing a bit what's being done so far by us and which is the status of this connection between QoE and QoS in the standardization and at 3PP level, very quickly, and basically have a discussion and basically maybe a brainstorm on what we could do to help steering or provide some inputs to the standardization community for the midterm future, let's say, because the situation is that right now the next generation, so 6G, is starting to be discussed at very, very high level in 3PP, and there's some high level ideas floating around in the environment. And it could be a good moment for us to have a word on that and contribute somehow to this whole ecosystem. So stay tuned and see you on Wednesday.
Thank you, Pablo. So we are now going to the emerging technologies group and having Nabajit back.
Yeah, hi. Let me share my screen again. I hope it's sharing now. Can you see these slides now?
Yes.
Yeah, hi everyone. It's me again, Nabajit. I am the chair of the emerging technology group together with Saman. So this group was created, I believe, last year in December, if I remember correctly, with the focus to actually explore new areas and research domains that might affect the current projects that we have in VQEG, right? So the idea was to look into the work that has been done in the MLAI community and how they are perceiving the quality and what challenges it brings to the quality estimation domain, right? So what we have done previously is we have invited researchers from different domains to introduce VQEG and also give a talk about the topic of their interest. The main areas that we explored in this was primarily on machine learning based compression, quality assessment and enhancement, and greening of streaming. So we had several invited talks over the past year from MPEG system smart contracts for media subgroup to quality assessment, the anti-IRE workshop on quality assessment this year for video enhancement and others. In the spring meeting, we had two presentations on super resolution and learning based image and video compression. And we had a very productive panel discussions, including our own VQEG members, G, Yanis, and Matthias, and Richard from Adobe. So this is, and since then we didn't had any invited talks because of summer break and other commitments. But what we have planned for this meeting is a more of a discussion session, like Pablo said in the previous one. What we are looking into is to discuss and get opinions and feedback from the VQEG experts here on how to tackle the challenge of quality assessment of AI generated or modified content. So that's the basic goal. And this is more of a discussion session rather than a presentation, and it's scheduled for Thursday, session 2 in the afternoon, the first presentation after the admin discussions. So again, if you have any questions or any comments, please feel free to contact me or someone. These are our email address, and you can find the details on the project homepage on VQEG. Thank you. Any questions, comments?
Thank you, Nabajit. Let's move on to the IMG group.
Yes, let me share my screen. Can you see the slides? Okay, so the Immersive Media Group is working on quality assessment of immersive media. We have covered and we are still addressing some of the technologies that you can see there in the slide, 360-degree content. We worked on a test plan, and that ended up with a recommendation on quality assessment for short 360-degree videos, and we are trying to extend it to long 360-degree videos. And we are also targeting or covering related works on virtual, augmented, or mixed reality, light field, and also 3D content like stereo, multi-view, or free viewpoint video, and even including HDR content. So the goals are to provide guidelines, data sets, subjective methods, and objective metrics that can work with or can help us to estimate or evaluate the quality of immersive media technologies. And currently, the main joint activity that we are working on is a test plan on evaluating immersive and interactive communication systems. We started this work some meetings ago, and we have, since the last meeting in spring, we launched it and we do like a kickoff of this test plan. So we have been progressing, I would say quite good in this sense. So we will present in this meeting some of the updates that we have made in this activity. You can see there our email reflector, and I'm sharing this group together with Pablo Perez and Sengshuan Cheng. In this meeting, we have a slot. The main slot will be on Wednesday, and we will, as I said, present the status of this IMG test plan on XR communication systems. That I have not said this, but it is in collaboration with ITU. There is a work item that is PIXC, and we are trying to contribute to this. This will be presented by myself, Pablo, Kamil, and Ashutosh, and some of the other researchers that are working on this test plan. The idea will be to provide an overall update of the test plan. Then we have divided the main test plan into 4 subgroups, let's say, related to the different tasks that we have been working on to address this evaluation of communication systems. And in each subgroup we will have some short presentations of the labs that are involved in them, that have been working on setting up the experiments, and probably they will even show some preliminary results. We would like to have some time for discussion, especially to discuss on the questionnaires, and the questions and questionnaires to use in these experiments, and we will also address next steps. Apart from this, we will have another presentation by Felix Seymour from TU Ilmenau on the impact of spatial audio on social presence and user behavior in multimodal VR communication. And we will have 2 more presentations on Thursday that are related to static and dynamic mesh databases. I don't know who are going to present this, but I think they are coming from Tencent Media Lab. And I think that's all from Immersive Media Group. Shell, if you want me, I can just give a few words on the CMM records initiative.
Yes, please go ahead.
So this is a dissemination initiative that we are following from June 2020.
and it's an opportunity that the special interest group of multimedia from ACM is providing us to publish updates or information about research and stories that we are covering here in VQEG. There is a section in this ACM CGMM records that is related to standardization, and we have columns there from MPEG, JPEG, and also from us, from VQEG. So these records are available in the CGMM website, but also in the ACM Digital Library, and also in the records website that you can see in the slides. And it's a quite good possibility to disseminate VQEG activities. What we have, I mean, there are 4 issues per year. And what we are doing right now is to use 2 of these issues to report on the plenary meetings, and the other 2 to update, I mean, or provide some info or talk about any other topic going on within VQEG. And any ideas, if you want to contribute or you want to share some information about your groups or your research, would be nice to let us know, Shell and myself. We have already worked on 10 columns. The last one was on July 2023 that we reported on the plenary meeting in Sony. And the previous one, as I said, there are 2 of these issues that are related to other topics going on VQEG, and we talk about Navajit and Saman provided a very good column on the initiatives covered by the Emerging Media Technology Group. The next publication will be on January 2024, so we will report on this meeting that is happening now, and if you have any other ideas or topics for the issue in April 2024, this is a mistake, they are more than welcome, so just let us know. Thank you.
Thank you, Jesus. Very good. So let's see. Now we are done with the main working group, and moving into the outreach. We also have another more dormant, let's say, way of disseminate, which is called the e-letter, and has not been any new issue for some time. So that's probably something need for a restart, but there is nothing to report there at the moment. So let's move on to if there are anything to report from human factors for visual experiences. I think it's usually Maria that's involved if she's in the meeting. If not, there is also something called the Joint Effort Group that doesn't have really any mission anymore. It was formed at the time where most of the project or working groups were competitive in VQEG. Since it's now more or less the main way of working, the group has not had any mission to perform for a long time. We have the joint Qualinet VQEG team on immersive media. That is a group that is kind of overlapping with the Qualinet network. It's the Qualinet meets nowadays once per year in conjunction with the COMEX conference, and a report on the task forces that they have. And the last meeting was just before the COMEX in Ghent in June last year. And you can find the information about Qualinet on qualinet.eu. And most likely the next meeting for Qualinet will be just before the COMEX in Karlshamn, Sweden next year in June. So, but the program is not finalized as yet, but that's the expectation. So let's move on to if there is anything to report from the Tools and Subjective Labs Test Setup Group. Is there anyone representing that in the meeting? For instance, Glenn. I haven't seen him yet, but okay, hearing none. We have the video archives and support and VQEG administration and web support. I guess those are both handled by Margaret. Is there any update there to give, Margaret?
Those are mine. So as usual, if you have any changes you'd like to see made to the website, please let me know. I will be having a slight delay before I upload the files that you send me for this week's meeting, but please do send them early. If you are able to share your slides, people appreciate being able to flip through your slides after the meeting or while you're presenting. So other than that, nope, nothing to report.
Okay, thank you. Last but not least, I think we have the IRG VQA, which is a joint rapporteur group for VQEG and no, for ITU, sorry, and where they can co-locate meetings and work that is both joint between the study groups and the R sector and the T sector, I think, and also with VQEG. And we have meetings organized, I think, by Julie on Tuesday, first session on Tuesday. So did we miss anything in this update? Hearing none, then I suggest we move on with the program. And then the next point on the agenda is the session of JEG Hybrid. So I leave the floor to JEG Hybrid and to take it from here.
Yes,
please.
Thank you, Shell. So first of all, we have 4 presentations in this session. The first one is very brief. It's given by me. That is about the status of JEG Hybrid and a few words about the IGVQN, about which I spoke a few minutes ago. I'm going to share.
Could I just interrupt before we start?
Yeah, sure.
I think this might be important to announce. Based on previous meetings about these recordings, and the recordings from the last meeting has been delayed just because we are not sure completely what could be published or not. At least that was the legal department of Sony had some doubt. So what we did was to do a column in the presentation document where you can indicate whether a certain presentation should be recorded or not. And ideally, we should then turn off the recording, but at least we can edit out the presentation if it by mistakes are recorded before we publish. So please, go in and fill out whether there is anything that you don't want to be recorded, so we can see that in the presentation list. Okay, sorry for interruption. Please continue, Enrico.
Yep, no problem. So for JEC hybrid, I think we agreed and we already put in the column that everything can be recorded. So we're fine for the first session. So let me share the slides for the first presentation. I hope you can see the presentation in full screen as well. Yeah. Okay, so this is a very brief update on the JEC hybrid activities, and especially I would like to say a few words about the IGVQM project. So I already told you this is this group comes. I mean, the name of the group comes from the original mission of the group that was to develop a no-reference hybrid preserved bitstream metric. But then, let's say, in the last few years, we focused the topic a little bit and more on about research. And as I said before. At the moment, there are 2 lines of research currently being pursued. The first one is trying to model single observer's behavior in subjective experiments, and Loic is online and we will present 3 works in a few minutes. So I won't spend more words on this now. And the second one is this IGVQM activity that we decided to move into JEC hybrid last year. We already have a page on our JEC hybrid website where you can see a few of the things that I'm going to present and a summary of what were the original focus of the group and what we are thinking to do now. At the moment, I can summarize the activities in these few slides. So we are going to use a large set of subjectively annotated datasets, basically to try to draft documents, publications, reports, documents in general, that explain how to correctly use these VQMs. And we plan to do these activities using open data and reproducible experiments as much as possible. At the moment, we are starting the work by using, well, one of the very well-known libraries here in the group, that is libbmap. Which is, by the way, open source, so it's easily reproducible by anyone. And also we are trying to use containers at the moment, which seems to us the most promising solution to achieve reproducibility in a wide set of environments. At the moment, I must say that we are exploring this format called named Singularity. This is one thing that personally I discovered just a few weeks ago, in the sense that it is it's not so, how to say, it's a container format which is maybe not so known as a Docker that you might have heard about, or its derivatives like Podman and so on, but it's very well suited to run on HPC systems. As you see, we have one available, and somebody else could be interested in using this format, which is somehow also compatible with Docker, etc. I can spend a few words on this if you're really interested in this activity. Also, we besides reproducibility and using a large set of video sequences in this activity. These were some of the original, goals of the IGVQM project. And we think some of them are still relevant for today's activities when incorporated in what we can actually do in JGuide. So we think this would be useful to offer standardized function or methods to do very common activities like temporal aggregation or statistical analysis. Since we start to run from we plan to start from data sets which are subjectively annotated, so we can do some statistical analysis comparing subjective and objective evaluations. And so we can also try to create some sort of standardized logistic mappings and things like this. At the moment, we are running the objective measures on some of the data sets. Some are quite large, and we would like to make them available in some standardized formats. We were thinking, for instance, to use the file format, the JSON file format used in the Surreal software by Netflix, which is, a very much used software in this group. And then, of course, we would like to perform statistical analysis and to come up with some documents in the form of reports or publications about what we found in this activity. And we will for sure present more results, more technical results in the next VQEG face-to-face meeting. At the moment, I can only say that we started working, let's say, actually working on the topic. So this is more or less all from this short introduction to the IGVQM activities in JGuide. If you have any comments, proposals, ideas on how to move forward, especially with IGVQM, and later when Loic is speaking with the rest of the activities, just feel free to tell us and ask questions and so on. We typically meet in bi-weekly conference call. Next call is next year, actually January 9th, and you're of course welcome to join, and so we can discuss what we can do in the group about the research activities. You can join the activities and so on. We have a website that you can visit to have a look at what we are currently doing and what are all the other line of research that we are currently pursuing. Okay, I think it's all from this presentation. If there are any questions, I'd be glad to answer. Otherwise, we can leave the floor to Loic for the next 3 presentations that he will introduce himself, I guess.
I am sharing my screen, so by the way, so tell me whenever you are able to see it, guys.
Yeah, we can see the Acrobat Reader. Yeah, in presenter mode. Yeah, you can go.
Nice. So thank you, Enrico. And hi, everyone. Once more, I'm going to present this work that is basically a summary of a work that we got accepted on IEEE transactional multimedia. The work is still to be published, and that's why the presentation will include a number of formula and stuff that I cannot really step in, but this presentation is basically meant to be used like a reference while waiting for the formal publication of the work. Yeah. And sorry, here, this, okay. The outline, I'm going to basically introduce you to a new approach to recover subjective quality from noisy raw ratings. And then we are going to introduce this idea of positional bias weight. Later, we will derive a scoring model that we'll use to also measure the inconsistency of subjects, show you some computational results on our proposal, and draw some final conclusions. So, yeah, typically raw ratings that we collect in the context of subjective experiment are noisy due to a large number of influence factors. And the common approach to deal with such a noise is basically to use statistical model. to recover the quality as well as highlighting peculiar behaviors. And in that context, one of the main ideas is that of assuming that a subject is characterized by a bias and an inconsistency. It is not the unique idea, but let's say that it's one of the most common one. And the work that I'm going to present adopt that same perspective, right? So, but what makes the difference is that instead of computing an overall bias, we believe that the subject have what we call here positional bias, that is a tendency to prefer a specific element or some specific element of the quality scale over the other. On the other hand side, our measure of inconsistency does not come from a model that we assume a priori, but instead we make some high-level assumption and derive a scoring model behind the behavior of the subject. So let me just quickly introduce you to the notation here. I will use I to index a generic stimulus, J to index a generic subject, K to index an element on the quality scale, F to index an influence factor. So Rij, for instance, is the rating of subject I, of subject J for stimulus I. Y, Nik is the number of time the item K or the opinion score K on the quality scale was chosen when rating the quality of stimulus I. Now, if we use that notation and look at equation 1 here, you can say that the mass of each stimulus can be computed as reported in equation 10 here, where basically the mass basically weight each item of the quality scale by its choice frequency. Now, we know that this weighting scheme with the mass is not a robust one because it treats subjects equally, like even if a subject is reliable or not, it receives the same weights as all the other subjects when computing the mass. But this formula in equation 1 can inspire us in defining a new estimator of quality. That's what we are putting here in equation 2. So for us, the quality on an ordinal scale, it's basically a weighted sum of all the opinion score on the quality scale, but we need to find the weight WIK in a way that they account for the fact that the data that we observe are noisy. And how can we do that? The point is that we can assimilate the weights WIK that basically represent the importance of the opinion score K in the determination of the count of quality of stimulus I. We can assimilate this weight here like to the kind of actual probability of choosing the opinion score K when scoring the quality of stimulus I. But we don't observe these probabilities, right? But if you assume that these are probabilities, then you can formulate a log likelihood function for the observed data and try to maximize that log likelihood as typically done. But if we just maximize that log likelihood function, what happens is that the weights that you get as optimal solution are still the frequencies of, so you will get WKI equal to Nik divided by the number of subjects, basically. That is the frequency of choosing the opinion score K. But we already say that this solution is not robust. So our idea was to introduce what we call here a regularization term that you was formalized here, equation 3. But this regularization term, it does what? So our idea is that probably opinion scores that are not frequently chosen when rating the quality of a stimulus are potentially noisy ones. So opinion scores that are just chosen occasionally. So if we introduce this CIK, that measure how surprising is to choose the opinion score I, the opinion score K when rating the stimuli I. And then our regularization term is just a weighted sum of these surprising measures. But the idea is then to put that regularization term into the maximum likelihood framework, but by subtracting it to the log likelihood function. Okay, the objective of the optimization problem here is to maximize the objective function. But whenever you subtract the regularization term, in order to maximize the objective, you will try to minimize the regularization term. And when trying to minimize the regularization terms, you will attribute less weight to the opinion score that are highly surprising. So that is our approach to attribute less weight to opinion score that are surprising and that's potentially noisy. And so the solution of this optimization problem basically gives you the weights that you can then use in this formula here at question 2 to recover the quality. So this is basically our way to recover the quality. Now, what about the bias? As I already said, okay, approach in Surreal, for instance, the Surreal software, for instance, the idea is that subjects have an overall bias, and this can explain many behaviors. But some of them, and it can also, it cannot be enough to it might not be enough to cope with all the possible peculiar behavior that you might observe in a subjective test. And in particular, I reported here 8 typical behaviors that, a paper that I found where typically in subjective experiment conducted in a discrete scale, you might observe some of these 8 peculiar behavior here. We are talking, for instance, about negative and positively biased are basically subjects that tends to choose large opinion scores, you already know. Competent annotators are those that you would like to have in your experiment, right? Those that really score the quality based on those that score the quality as you expect that that it should be. Then you have spammer annotator that just give opinion score at random. But those that are really interesting are this unary, binary, and ternary. Unary annotator is the one that always tends to choose the opinion score in the middle, right, of the quality scale. Binary choose the lowest and the highest. Ternary choose the lowest, highest, and the one in the middle. So it's kind of the subject that quantize the quality scale. And the adversary annotator, kind of annotator that misunderstood the task, and when the quality is top, they give 1, and when it is excellent, they give, when the quality is excellent, they give 1, and when the quality is bad, they give 5. But for sure, not very frequent in our context. But these are some behaviors that you might observe in a subjective test conducted on a discrete scale. Now, if you focus on unary, ternary, and binary, you basically understand that it's clear that if you want to model the behavior, maybe it makes sense to consider the fact that a subject might have a systematic tendency to prefer certain opinion score over another. So that's why our definition of bias it's as follows. We define this mu kji that stands from the systematic tendency of subject j to prefer the opinion score k, right? And how can we estimate this mu kji or this bias, this positional bias weights? You can, if a subject give, for instance, a 3, you can codify this 3 as a 0, 0, 1, 0, 0, for instance. This means that in that case, this way of codifying the information or the rating represent more or less the weights that the subject is attributing to each item of the quality scale, and subtract this codified version and make a subtraction between this codified version of the rating with the weight that we derive it for the quality. And if you average all this subtraction here, you can get an estimate of the systematic tendency of the subject to prefer the opinion score K over the other. So this is our idea to estimate the positional bias weight. Now, if one of the property of our estimation is that if you sum up all the bias weights of the positional bias weight of a subject, they will go to 0. This means that certain bias weights are positive, meaning that the subject prefer to choose those opinion score, and others are negative, meaning that the subject, tends to avoid those opinion score. For instance, a unary subject will have one bias weight, the one on fair, for instance, that is very positive, and the other are all negative. On the other hand side, maybe for comparison sake, you might want to compute also the overall bias of the subject. And then you can simply weight each item of the quality scale with the corresponding bias weight and get the overall bias of the subject. Now we have quality, we have bias. What about inconsistency? As I said before, we didn't want to assume a scoring model a priori to say that the opinion score IIJ follow a specific probability distribution. Instead, what we did is that we believe that in a subjective test, when we ask people to rate, when we ask a subject to rate a stimulus, what he does is that he unconsciously attribute an attractiveness, a stochastic attractiveness to all the opinion score on the quality scale, and basically choose the one that have the highest attractiveness for him. And this attractiveness depends basically on the quality of the stimulus that he's rating, on his own tendency to prefer certain opinion score over others, and there's many influence factors that might impact on the subjective test. Now, how do we model such an attractiveness? From our point of view, the attractiveness of subject J for the opinion score K when rating stimuli I is the sum of three components. The first component is the importance of that score of the opinion score K in determining the grant of quality of the stimulus. Then the systematic tendency of that subject for that specific opinion score, plus a random variable modeling the influence of the different influence factors. Now, obviously, in practice, there are so many influence factors. So we cannot really assume, we cannot just make an assumption we cannot just assume that the probability distribution of the random variable modeling the influence factor have a specific distribution. But we can make just some mild assumption on it in order to reach a close probabilistic scoring model behind the scoring behavior of the subject. And let me quickly discuss this assumption. Again, a lot of formulas here, I'm not going to step into it, but the idea is that there are many influence factors, but our assumption is that at the moment in which the guy makes his choice, mainly we can assume that only one of the influence factor with the maximum relevance really impact on his choice. So that random variable theta here, that is modeling the effect of influence factor, can be seen as the maximum of a series of all of random variable indexed by F, each representing the effect of different influence factors. So for us, theta should be the maximum of a series of several random variables. Now, we also require that, as I said before, we don't know the distribution of theta. We don't want to know it. It's difficult to know the exact distribution. But what we can say is that we just require that that distribution have a heavy tail or a tail that decrease exponentially. This is a mild assumption. It's the assumption that is depicted here with the question number 10. It's a mild assumption because it holds for normal, logistic, Laplace, for many distribution of common use. So it's not really restrictive. If those assumptions hold, then we can prove the following. We prove the following theorem in our paper. But it is important to remember first that in practice, the influence factors are are huge. So it makes sense to use a theoretical results that hold when the number of influence factor goes to infinity. So if the number of influence factor goes to infinity, we have this closed formula that gives the probability that the subject I will choose the opinion score K, that the subject J will choose the opinion score K when asked to rate the quality of stimulus I. Okay, and basically this theorem here yield our model, because what we are saying is that the opinion score Rij is distributed according to a discrete random variable whose probability distribution is given by this theorem here. Now, in this theorem here, you see this parameter beta j that is indexed by j. So it's a parameter that depends on the subject. And it is this parameter that strongly links this theorem to the subject inconsistency. Because what happens if this beta goes to 0, then the numerator of the formula become 1 and the denominator become k. So if the beta of a subject goes to 0, that subject is just picking the opinion score at random. It's very inconsistent. So this is a simple way to illustrate the relationship between beta and subject inconsistency. But in general, we strongly believe that a single parameter hardly, capture all the aspects of the subject inconsistency. Just to give an example, the subject inconsistency might really depend on the quality of the stimulus that is being rated. That's why to be more general, we define the inconsistency of the subject as the variance of Rij. So we just say in this slide here that Rij is a random variable, and the inconsistency of the subject J when rating stimuli I is basically the variance of that random variable. And we can express this as in equation 12 here. It depends on beta, but also on the weights that determine the quality and also the bias of the subject. And again, for the sake of comparison, we can average the different inconsistency over the sequence to get what we call an overall inconsistency of the subject. Sake of comparison with other approaches that just compute one value for the inconsistency. Now, how can we estimate this parameter beta? Because the unique parameter that we still need to estimate here in this model here is beta. And to estimate it, we have our theoretical variance here at equation 12. But we have the opinion score of the subject J that we call it. We can put it on a single vector that we call Rj here. We have already recovered the grant of quality of all the stimulus. We can subtract these two vectors here, compute the variance of the difference to get what we can call the observed variance for the subject J. So we have the theoretical variance that is here, equation 12. We have the observed variance. But by performing simply least square fitting of the theoretical variance to the observed one and finding the beta that optimize this Euclidean norm between the two quantity, you can get an estimate of beta, right? To get one beta for each subject. Now, let me quickly, just give you a short, introduce you quickly to the results that we got. A typical approach to compare these quality recovery approaches or peculiar behavior identifications is to take, a noiseless data set, consider the mean opinion score in that data set as, a reference quality, then add a synthetic noise to the data set, recover the quality on the noisy data set, and compare it in terms of root mean square error to the noiseless data set, to the quality that you have on the noiseless data set. Clearly, the lower is this root mean square error, the better is the approach. And we did the simulation. We started by considering the case where a certain proportion, a certain fraction reported on the x-axis here of the opinion scores of all the subjects are replaced with numbers, with random numbers taken taken between 1 and 5. Okay, and this case, in this case, we were trying here to simulate maybe the kind of noise that will be caused by subject fatigue or just subject distraction. Like all subjects might have a small probability to give a wrong opinion score. If you in this setting here, what we saw is that RMLA perform, really very well as compared to other approaches. The other setting was that we kept and changed the opinion score 50% of the subject, and just add noise to the opinion score of the other 50% of the subject. This was to consider the case where maybe you have experts in your experiments, you have naive raters, and the complexity of some stimulus might confuse naive raters, while the expert will still give accurate opinion score. Also in this setting here, our approach that is called RMLA, that stands obviously for the fact that we regularize the maximum likelihood. It was performing also better than other approaches. And later, we tested the robustness of RMLA, of our approach, to the introduction of spammer annotator into the dataset. That is, we take the dataset, we just put new subjects, the rating of new subjects, and these new subjects are just obtained by simulating, by just simulating, numbers at random. And surprisingly, in this case, RMLA was not very competitive. It was working, not as good as Surreal and other approaches. On this slide here, there is another approach called ES-square that is the topic of my next presentation. Coming to the ability of our approach to identify peculiar behavior, we compare it to Surreal in terms of overall bias and overall inconsistency of the subject. Remember, I told you that you can compute also an overall bias and overall inconsistency. If we just stop at that point, like looking everything at the level of overall bias and overall inconsistency, the output of Surreal and our approach are very aligned, right? I mean, there's almost no difference. The things are strongly correlated. Both the overall bias and the overall inconsistency are strongly correlated. Just note that the experiments are done here. We did this experiment here with the Netflix public dataset that we integrated by simulating 6 peculiar behavior, unary, and so on. Okay, but what our approach brings are new insights into trying to explain the source of peculiarity that we observe. And for instance, looking at this slide here, both approach says that subject number 10 is positively biased. And one wonder, this subject is biased because when the quality is bad, he gives poor, and when it is fair, he gives and when it is fair, he gives good, or whether there is another explanation of that bias. Something like questions like this. You can also see that subject number 7, 6, and 14 are more inconsistent than the other. What is can we have some insights about the source of this peculiarity? And in fact, if we look at the positional bias weights that we introduced before, we can start getting, we can have some insight about the source of the peculiarity that we observe. In particular, subject number 10 here, if you look at the row corresponding to subject number 10, you will see that he had a very large bias, positional bias weight on 5, and also a positive bias weight on good, but all the other bias weights are negative. So his bias comes from the fact that he tends not to use the left part of the quality scale. It's not that he's just mapping, he's compensating the fact that he's not choosing bad with poor and so on. No, his bias comes from the fact that he's not really using the left part of the quality scale. Another example could be maybe subject number 14, where you see that if you look at the bias weight of subject number 14 on fair, it's very high compared to other bias weight. So a kind of small tendency to be a unary one, right? And yeah, I mean, there are other examples that are written there. We cannot really go through all the examples. But what is also interesting is the ability of our approach to highlight the positional, the behavior of the peculiar annotator that we simulated. Like, for instance, you see the unary here that have very high bias weight on fair. The binary have the bad and excellent that has high bias weight, and the other have negative bias weight, and so on. So this is an illustration of how working with positional bias rather than the overall bias could help in better understanding the source of peculiarity. Also, obviously, the inconsistency that we derive from the model, we analyze that inconsistency as function of the quality, and we compare again, for instance, to Surreal here. Obviously, by design, Surreal compute an inconsistency that does not depends on the quality. But instead, we were curious to see whether our scoring model mimic the lower inconsistency of the subject at the extreme of the quality scale. And if you look at the heat map at the left, at the right, that represents the inconsistency as computed by from our model, you see that at the extremes of the quality scale, all subjects have lower inconsistency. But it is also interesting to have this kind of analysis because it's basically also tell you in which part of the quality scale the subject is inconsistent. For instance, if you remember the subject, I told you that subject number 7, if I go back here, we saw that subject number 7 is inconsistent because he tend not to use the opinion score excellent, if you look at the bias weight of subject number 7 on excellent, but he don't compensate that by choosing good. Instead, he prefer choosing fair. And if we come back on the inconsistency here, we see that on the top part of the quality scale, subject number 7 is inconsistent. It's kind of, you know, to say, okay, you basically do this analysis to see in which area the subject is more inconsistent, where he's not inconsistent, and so on. And yeah, I mean, to conclude here, what we can say is that in terms of robustness, our approach to recover the equality is robust to noise that is uniformly distributed over all subjects or part of subjects, but not very robust to the presence of spammer annotators. On the other hand side, the introduction of the positional bias somewhat give new insights into, you know, analyzing or trying to explain the source of peculiarity that we observe with overall bias and overall inconsistency. And the derived scoring model somewhat model the lower inconsistency of the subject at the extent of the scale. I think, I mean, at least from our point of sight, there is one open research question still here. You see that we progressively estimated everything, quality, then bias, and finally the inconsistency. But we are just wondering whether we could find, you know, a unique approach to just fit this model here, this model here, by using any statistical framework, will be MLE or Bayesian method and anything, to estimate everything at once, right? To really understand whether this model fits the data and so on. Yeah, so this is the open research questions. And we are just wondering if you, from this short presentation, you do see any other, that will be great. So thank you for your attention and looking forward for your questions.
Yeah. Thank you, Loic. Actually, there's one, Lucas.
Yeah, thank you so much, Loic, for the presentation. One thing that I missed, and I'm not sure if it's there, is did you look at the potential impact on the, or even a way how to calculate confidence intervals? Because those would be very interesting for future use. And if with this method you would get a, like, let's say, more narrow confidence intervals from overall scores, that would definitely be useful. That's one thing. And the second one is just, if it's possible, I would definitely encourage you to implement this in a serial package, because then it would make it much easier to be used widely, even with libvmath and other use cases that Enrico was talking about at the beginning.
Yeah. Thank you, Lucas, for the question. Indeed, I mean, it was just for the time I did not put result regarding the confidence interval stuff. But as I told you on this slide here, I told you that we can assimilate the weight WKI here to the probability, to the ground truth probability of choosing the opinion score K. And this somewhat gives you a kind of discrete distribution of the ground truth quality. And we use this discrete distribution here to approximate the confidence interval. The results that we got in our paper indicates that most of the time, for instance, the confidence interval that we obtain are shorter than those that approaches such as Surreal or Zereg, and no, Surreal mainly. I'm not sure that we compare it to Zereg, that is a recent approach by Patrick. But yeah, so in short, we use this weight here, we assimilate this weight here to the ground truth probability of choosing each opinion score, using this probability distribution here to compute confidence interval for the quality. And in general, they are shorter than those computed, for instance, by Surreal. And regarding the comment to the way to your comment on integrating everything into the Surreal package, I would really like to do it. Just struggling to find the good, you know, time step to implement everything. And for sure, I have many other things that encourage me to send to you for your validation and inclusion in the Surreal package, and I'm working on that. Yeah, thank you.
Sounds good. Thank you so much. Yeah, if you need anything, let us know.
Okay, nice. Thank you, Lucas.
Margaret, please.
Thank you for a very interesting talk. That's an intriguing idea. Have you considered looking at the data sets made available, the CONE-VID and CONE-IQ data sets? I know the crowdsourcing and what you were presenting was more lab studies, but I found them to have some really unusual behaviors And the Cone IQ 10K data set in particular, I found very frustrating that the ratings with MOS above 4 seemed almost random. And I'm wondering if your specialized screening technique might address some of those problems.
Yeah, definitely a nice point, Margaret. I mean, at the time we published the work, we wrongly the mistake that we made is that we test everything on the data sets that we had and just with synthetic noise. But right now that we are suggesting, I think it will be a really great step to test this on crowdsourcing data set as those that you suggested, to really spot out, to evaluate the ability of this more detailed model here to figure out peculiar behaviors. Yeah, definitely it's a step that we still have to do. Yeah.
Well, certainly, but I think it'd be very interesting to see your results, because some data sets are excellent as it is, and some of them, there's just a few quirks that it would be wonderful to clean up.
Definitely.
So thank you.
You're welcome, Margaret. Thank you. Okay.
Thank you. Ali?
Hey, Loic.
Hi,
Thanks
Ali.
for the presentation. It was nice to also finally hear the whole paper from you. We had a few discussions. I was wondering, with Giuseppe, we had a little bit of chat, but we didn't discuss these. We didn't have the details at the time. But did you also check the accuracy of this confidence interval estimation? Because when we checked it on our side during analyzing the results we got with ZIREC, we also had slightly lower confidence interval ranges than the serial, but also slightly lower accuracy of the confidence intervals. So it was kind of, I think, a trade-off. I would say if we equalize somehow, like, tinker with the parameters, I think it would have been the same kind of confidence intervals on our side. And you said similar results you acquired as well, that it was lower than serial and ZIREC. And do you think it is it comes with a trade-off of lower accuracy of the CI ranges?
Okay, now regarding this particular model here, this RMLE here, I can confirm that RMLE, I think is ZIREC, that is your approach basically. We will see on the other presentation, but ZIREC, I think, computes smaller confidence interval than RMLE in general. I think it's better than, I'm also for our experiments, we saw that ZIREC does better in terms of confidence in interval estimation with respect to serial a bit. And but for this specific work here, I don't think that we use the ZIREC, I think, for this specific work here only in terms of this robustness to noise stuff. And our conclusion was that ZIREC basically have similar performance to serial for this task here. But regarding confidence interval, on the result that you're asking me about, I know that we had a chat, if you remember, and finally I told you that, yeah, we have verified everything. And I do, at least again for our experiments, the sensation is that there is a small improvement in using the ZIREC with respect to serial when it comes to the confidence interval estimation. And I'm going to present to my second presentation. We give more details and we show the results that we got on that purpose. So, I mean, our discussion was mainly for that other work rather than this one. That was by the time already published. Yeah, already at least already sent for publication.
I understand. Thank you.
You're welcome, Ali.
Thank you. Any other questions? Seems not. So I think you can, Loic, you can go to the next presentation.
Okay. That should be this one. Yeah. Okay. Let me make it presentation mode then. Okay. So this is again summary of a work that we recently submit still to IEEE transaction on multimedia, still on the question of how to recover subjective quality from noisy opinion score. But we change a bit the setting, right? So we propose a non-parametric approach to solve the problem. That somewhat contrasts with usual parametric approaches. And our approach is called entropy-based subjective quality recovery approach, and we will see the reason why later. We will discuss some computational results and draw final conclusions. So let me use this diagram to illustrate the difference between our non-parametric approach and the traditional parametric approach to subjective quality recovery. The usual approach is to assume that the opinion score of the subject follow a certain probability distribution that is characterized by certain parameters. So we call that a model F theta, where theta represents the parameter. The next step is to estimate the parameters, and then got the ground truth quality from the estimated parameters. What we did is to say, let us try not to explain the scoring behavior of the subject, but just try to measure the reliabilities of the opinion score that we already observe, and then use that reliability information to derive a robust estimate of the ground truth quality of the stimulus. Now, if you are under such a setting, what are the advantages of parametric approach as compared to non-parametric one, and the vice versa? What we see is that parametric approach makes an assumption that tries to explain the scoring behavior. On the other hand side, there are some disadvantages with parametric approach. The first one is that typically the model that you propose should be simple enough to guarantee numerical stability. And this the fact that the model is simple somewhat involve restrictions for application, making model not robust for all applications. Also the problem in order also to guarantee stability, sometimes you need to not put so many parameters into the model. This brings into the loop problem of some problems such as underfitting or overfitting. And the last and crucial problem with parametric approach is the parameter estimation process. If you want to get the optimal value of the parameters, then you need usually to solve an optimization problem. And this is somewhat computationally demanding. But the non-parametric approach that we propose here have the inconvenience that we see is that, as I said before, we don't try to explain the scoring mechanism of the subject. On the other hand side, since we are not making assumptions, we get an estimate of the quality that is expected to be more robust to noise, have no risk of overfitting here because we are not fitting a model to the data. And also, we don't have to estimate parameters. So this is somewhat how we can compare the two perspectives. Now, if we let me introduce this notation here again, I'm going to index the stimuli with I, a subject with J. So for instance, IJ stand for the stimuli rated by subject J. JI stand for the subject that rated stimuli I. But now, please, I will ask you to pay attention to this the definition of VI and PVI. So for us, for a given stimulus I, there are several accurate opinion score, and VI is a random variable that describe accurate opinion score for the stimulus I. And PVI is the distribution of accurate opinion score for the stimuli I. On the other hand side, RIJ or RJI is the random variable that models the response of the subject J when asked to rate stimuli I. And RJI is the probability distribution of that random variable. I mean, again, this lot of notation, but I will try to. Okay, this is, I said before, our idea is to introduce a definition of reliability. So we give this abstract definition of reliability, and then in the next slide, we will try to motivate why it is actually a measure of reliability. So given the opinion score RJI, we define the reliability of that opinion score as 1 over the likelihood of observing that opinion score, given that the distribution of accurate opinion score is PVI. So this is an abstract definition, right? In particular, we don't know, we don't have PVI because you don't observe the distribution of accurate opinion score. You don't know it, so you cannot even compute WIJ. That is the reliability. But for the moment, let us assume that we know it and try to motivate this definition. We'll come back later on how to make a non-parametric estimation of PVI. Okay, so I will introduce two quantities here to motivate the fact that WIJ is a suitable measure of reliability. The first thing is that if you remember, I told you that this PRJI is the probability distribution of the opinion score of the subject J for stimuli I. The entropy of that probability distribution measures the inability of that subject to repeat his opinion score if he is asked to read that stimulus several times. So it's basically the entropy. You can use the entropy as a measure of the inconsistency of the subject with himself. On the other hand side, you can use the KL divergence between the way the subject is rating and the distribution of accurate opinion score to measure the inconsistency of the subject with respect to the distribution of the accurate opinion score. So AJ is a measure of the inconsistency with himself, and BJ is a measure of the inconsistency with respect to the inconsistency of the subject with respect to the distribution of accurate opinion score. And so AJ plus BJ, it's a measure, it's an overall estimator of the overall unreliability of the subject. Now, if you manage to make a link between this WIJ here, that is our measure of reliability, with these concepts here, then we have a motivation of why WIJ is a measure of reliability. And in fact, if WIJ is a measure of reliability, then WIJ to power -1 is a measure of unreliability. So we expect this SJ here to be an overall measure of unreliability of the subject J. And we can state and prove we state and prove this proposition here that basically says that if the subject J rates a large number of stimuli, then SJ will converge to the inconsistency of the subject with himself and the inconsistency of the subject with respect to the accurate behavior. So this is one way to motivate why WIJ is a measure of reliability. I mean, if you're not convinced, we can also try to look at individual terms, right? Because we work with the average here. But what about each WIJ by as individual terms? If I go back here, WIJ is defined this way. In the information theory, the logarithm of the probability distribution evaluated at a specific point, it's called, evaluating a specific event is called the self-information of that event. So the logarithm of the denominator of this formula here measure the information that is contained in the event of giving Rij as opinion score for the quality of stimuli J. So if an event is surprising and then potentially noisy, then it comes with a lot of information. On the other hand side, if an event is not surprising, it's something that we were expecting, and in general, we expect accurate opinion score. So accurate opinion score are normally not surprising, and that's why the less is the surprise, the more reliable should be the opinion score. And this denominator here basically measures the surprise. So this is another way to motivate our definition of reliability. As I told you before, we don't observe PVI here. We don't observe this distribution of accurate opinion score. So we cannot estimate, we cannot compute this W. What we can do instead is to find, sorry, a reasonable estimate of PVI in order to estimate also W, the reliability. But remember that what you observe is a set of noisy data. But for that noisy data, you can estimate the distribution of the opinion score that a subject will give for a certain stimuli. So we have an estimate of this distribution's PR here. And if you want to make a non-parametric estimation of PV, what you can do is basically take a weighted sum of the distribution of the opinion score of the subject for that particular stimulus. But you don't want to give the same weight to all the subjects. To get something that is more, more robust to noise, you can say, I want to weight subjects differently and giving more weights to subjects that are more trustworthy. And how can you how can you do that? An idea is to measure how each subject correlates to all the other subjects and compute the weights of each subject based on his correlation to the other subject. That is what we did to compute the different weights and then basically weights the different distribution coming from different subjects to get an estimate of PVI. I mean, for sure, on one slide, everything might not be clear, but the idea is just to say that we did is, we implemented a simple idea to get a non-parametric estimate of PVI. That is the distribution of accurate opinion score. But in an ideal world, if you knew exactly what is the value or what is the distribution PVI, you could just say that the ground truth quality is the expected value of the random variable whose distribution is the distribution of accurate opinion score. But as you see here, we just have a not sophisticated estimation of PVI. So we try to take inspiration from what will be the ideal ground truth quality to define our estimate of ground truth quality and say, okay, the ideal ground truth quality is a certain function of the distribution of accurate opinions or of accurate opinion score. But okay, we don't have the right value of PV. So let us define our estimated also as a certain function of our estimate of the distribution PVI. But this function G differs from the function F because we need to take into consideration the information related to the reliability of each single opinion score. So at the next step, we'll try to derive our function G to be applied to our estimate in order to get a robust estimate of the ground truth quality of each stimulus. Now, okay, what is the idea? It's that of saying again, we have a measure of reliability. Why not trying to give higher weight or higher importance to opinion score that have higher reliability in our process of estimating the quality? And now we can estimate the reliability of each opinion score using our estimate of the distribution of accurate opinion score. And once we have that estimate of the reliability, we can define what we call the importance of the opinion score, of each opinion score, right? So this omega here is basically a normalization of the reliability of the opinion score Rij to get how important should be that opinion score in the process of deriving the quality. So it's just a way to weight the importance of each opinion score in the derivation of the ground truth quality. In fact, we can now define our estimate of ground truth quality as a weighted sum of the observed opinion score, where each opinion score is weighted by his normalized reliability. Okay, this is our algorithm that we call ESQR, or entropy based subjective quality recovery. Entropy just because, as you see, the link between the reliability and the ability and the behavior of the subject happen with the concept of entropy and KL divergence that are all stuff related to entropy. So we call our algorithm entropy based quality recovery. And it's a very simple algorithm that implements 6 steps. Like, we quickly compute the correlation between pairs or subjects. Use this correlation. We use the Fisher Z transform to get the overall correlation of one subject, of a specific subject, to all the other subjects. Use this information to estimate in step 3 and 4 the distribution of accurate opinion score. And from that distribution of accurate opinion score, we estimate the reliability of each opinion score and use this reliability to compute the quality as a weighted sum of the observed opinion score. And each opinion score, again, is weighted based on how reliable it is. The output is the quality for each stimulus. Now, what we realized by simulation is that this estimator here, if we have enough subjects, if more than 20 subjects rated the quality of stimuli I, then the probability distribution here, this probability distribution of this estimator here approximate that of a normal distribution. So it is easy to compute the confidence interval. And what we did is that you could estimate the standard deviation of that of the estimator of the quality as by using this weighted sum again also of the deviation between the opinion score and the ground truth quality. Once you get that standard deviation, you basically can use it to compute the confidence interval, the 95% confidence interval of the estimated quality. Now, let me show you some results. The first thing that we asked ourselves is we computed ESQR to existing approaches in terms of what is the approach that compute the quality that recover a quality prone to lower uncertainty. And the typical way to evaluate how the quantity of uncertainty that affect the estimation is to use the size of the confidence interval. And this table here summarizes the results. Also note that we measure in terms of percentage how each approach reduce the confidence interval as compared to the MOS. And in general, you see that the ESQR computes smaller confidence interval or compute a quality that is prone to lower uncertainty. But the issue with this sort of evaluation is that in a real data set, you don't have a ground truth confidence interval to compare your estimation with. So it's okay to compute smaller confidence interval, but can you really say that ESQR is not just underestimating the size of the confidence interval, but is it really predicting? Is it making a better prediction than other approaches of the confidence interval? That's why we made use of simulation. So basically, we simulated the ratings of 100 stimulus in a way that we knew exactly what is the ground truth confidence interval. So in simulation, you can set your ground truth and basically put some noise and check which method predict better the ground truth. So we made this simulation in a way that we knew for each stimulus what is the ground truth confidence interval of its quality, and then use the different approach to predict the ground truth quality and assess the prediction accuracy of each method using two main indexes. The first index is this delta, the delta of each method. The delta is basically the distance between the center of the predicted confidence interval and the center of the ground truth confidence interval. Rho instead is the ratio between the size of the predicted confidence interval and the size of the ground truth confidence interval. I mean, we want delta to be close to 0, or we want rho to be close to 1. This table here summarizes the results. In terms of prediction of the center, you see that Surreal, Zerek, and ESQR were the best approach. In terms now of prediction of the size, ESQR, we believe ESQR performed better than other approaches, in the sense that ESQR slightly underestimated the size of the confidence intervals, while other approaches overestimated the confidence interval, like with something around more than 20%. And I mean, the next experiment is the robustness to noise. The setting is exactly as I told you before. We compare in terms of root mean square error, the quality recovered on the noiseless dataset to the one recovered after adding some noise to the dataset. In the setting where we put a few noise to all the subjects to simulate subject fatigue or distraction, ESQR performed well. We already saw that RMLE performed also well in this setting here. ESQR, so in this setting here, ESQR and RMLE performed better than the other approaches. But again, when it comes to spammer annotators, what we can say is that ESQR compete well with Surial and the REC for when we add spammer annotators to the data set and ask ourselves which approach it's robust. So the point here is that this result basically match our expectation, right? You see that ESQR is not really sensitive to the application scenario. It shows great performance in both cases. Why the other approaches are good in one case, not good on the other case? Probably this is due to assumptions that you make when you are deriving your parametric model. So that is, from our point of view, one advantage of adopting a non-parametric perspective. Now, the last two slides. Another experiment that we did. Remember, we computed the importance of each rating in the determination of the grant of quality, that omega ij that I showed you before. Also, Surial does something similar. Like Surial use the inconsistency of the subject divided by the sum of the order of the inconsistency to weight the importance of the weight of the subject. Now, remember, by design, the inconsistency Surial does not change with the stimulus. That's why the weight, once the Surial estimate the weight, the contribution of the subject, this will be the same contribution for all the stimulus. Instead, ESQR computes something that changes from stimulus to stimulus. That is another advantage of using not parametric approaches, because you can do this without introducing a lot of parameters, right? But the advantage of having something like this is that, for instance, Surial, if you look at the mapping here, Surial tell you that the subject number 24, for instance, or subject number 17, all the opinion score of those subjects are really have very high importance, okay? Because in general, the subject is very consistent. But if you look at the corresponding column to the mapping, to the heat map at the right, that is the one of ESQR, you will see that for few video sequences, you will see a blue, that the value of the reliability is not that high. Okay, and we saw that those few cases where the subject is not very reliable. On the other hand side, you will see that subject number 7, for instance, here, it's in general a highly unreliable subject. But if you look at the corresponding column on our mapping here, you will see that there are cases where his opinion score should be highly considerate in the determination of quality of grant of quality. For instance, we saw that in some cases that subject even gave the mode, okay, the opinion score given by the majority of the subject. On the other hand side, you see that if you look at the row that corresponds to stimuli number 19 here, you will see that ESQR give the same importance to all the subject for that row. It's basically because all the subjects agree on the same opinion score on that stimulus. So it's normal to give them the same importance. But this won't happen in the case, for instance, of Surial, where you use few parameters to summarize the thing. Obviously, it's performed well, but you somewhat lost the possibility, this possibility to really capture it, to effectively measure the importance of each single opinion score. Now, this is my last slide on this topic here. We compared the output of ESQR to the output of other methods to recover quality. In general, as you will expect, ESQR and other approaches are strongly aligned. The idea is not to come out with a new quality recovery approach that just say that disagree with existing approaches. No, but instead, we expect these approaches to differ with existing approaches in a few cases, where maybe the assumptions made by one model hold when does not hold, and so on. And for instance, this is the example. This is one PVS. This histogram that I am showing here. I hope you can see my mouse. The histogram to the left. It's one PVS that we took from the Netflix public data set. And you see basically that there is a high difference between the MOS and the output of ESQR. In fact, the ESQR predicted a quality that is greater than the MOS. And our explanation is basically that this opinion score here, the one that gave bad, it's potentially a noisy one. And ESQR, by giving a higher quality than the MOS, is just giving lower importance to this opinion score here. We also compared ESQR to Surreal, for instance, on a crowdsourcing data set. It's not very a data set that focus on quality assessment, but this movie lens stop is just like a generic evaluation, I think, on a set of films and so on. I'm not really thought to be a media quality assessment data set, but it's still, you know, worth testing approaches on it. But in that case, in that crowdsourcing data set, you see that ESQR and Surreal mainly differ at the extremes of the quality scale. And our explanation of that is just probably, it's basically hard to really believe that, you know, the Gaussian assumption made in Surreal really hold when you approach the extremes of the quality scale, right? And for instance, this is the example of the stimulus where there was the greatest difference between ESQR and Surreal. We are talking about a difference of 0.5. That is significant on the scale from 1 to 5. And again, in this case, ESQR estimated a greater quality than Surreal, probably because it's given, you know, lower importance to opinion score that are the like to an opinion score like excellent here. That is very strange for a video sequence for a stimulus for which most of the people believe that the quality is bad. I mean, sorry. In conclusion, what we can say is that ESQR is in general very robust to noise, as this is a usual characteristics of non-parametric statistical based approaches. And it being a non-parametric approach, it allows you, you know, to be more detailed in measuring, to have more detail in the process of measuring the reliability of opinion score, because you don't care about parameters, you don't care about stabilities and stuff like this. And also in general, it correlates well with the existing approach, but in few cases where assumptions made by parametric model are violated, it might give a different quality than parametric approaches. 2 quick questions. The first one is that if you want to, we use pairwise correlations, for instance, to estimate the distribution of acquired opinion score. But in crowdsourcing experiment, for instance, not all the subjects grade the same stimuli. So it's difficult to compute pairwise correlations. We are still wondering how to best generalize ESQR, you know, to those contexts. Okay, we have an implementation of ESQR for crowdsourcing. It's the one that we use here, but it's not very optimized yet as the one that you have for lab experiments. And finally, our measure of reliability is based on entropy concepts. And the entropy is known to not care about the ordinal nature of the scale. We are actually trying to generalize our measure of reliability by using some other, you know, some other statistical tools that care about the ordinal nature of the scale. So thank you for your attention. I'm looking forward for your questions.
Yeah, Lucas, please.
Hey, Loic, thanks so much again. I've got a bit of a question or concern regarding the graph that you showed about, you know, this one, where you've got the subject and then non-subject, because I believe that that's the one on the left that Cyril is using is a feature by design, and that's how we have been thinking of unreliable subjects. It was basically the subject, if they are a spammer, you just don't want to look into their scores very much, even if they are right. Because I can imagine that you have like subject that's going to be scoring 4s all the time, and obviously at some stimuli you will have the 4s, and then you say, oh, actually they did well, so we're going to use that towards calculating the confidence intervals, and it makes them nice and narrow. But the added value of that person is really not there. So I'm just wondering how you think about this particular cases, and if there wouldn't be a way of actually making it more towards the more traditional, like, yeah, if you see that in a certain percentage of cases, the person is just not really hitting the mark, just to disregarding them completely.
Yeah, thank you, Lucas. In fact, if you, my introduction of this slides here was clearly to say that by design, Surya is like that. It's it's clear. It's not something to. I mean, it's not. I'm not trying. It's not a criticism, but rather, you know, the question that I'm asking by this slide is there. I mean, how difficult it is to let parametric approaches do something that like the one that we are doing here with non-parametric approach on the right, because for sure you can try to make your parametric model more complicated, and then what will happen is probably that you will get computational issues with the stability and stuff like this. I mean, just to say a bit, the model, the parent model from which the model of Surya comes from is the work by Lucian and Margaret. In that particular work, Lucian and Margaret really, you know, they define an inconsistency per stimulus, right? Not a general one, as later it was done in Surya. But what happened, I mean, progressively, I was discussing with Z, and he was telling me, for instance, that the ambiguity, just, you know, just to, when you want to really understand whether there is stability in the estimation of ambiguity of the source, and then there is yet an issue. So I mean, the takeaway from this slide was, okay, parametric approach are nice. They really summarize things as Surya is doing. Surya is doing well. In fact, we expect that if you average all the columns of our ES-square stuff, hopefully we will get a mapping like the one of Surya. But the question was, can we also get detailed information by using parametric approach as we are doing with a non-parametric approach here? So that was the main message from this slide.
Yeah, just a quick follow-up. So I may have given a wrong impression of being defensive of what Cyril is doing. That's not the case, and I love the fact that we could be potentially moving to the non-parametric solutions. Mostly this was a concern of if we are not really, you know, overly fitting to the data or something like that when we're creating a model like this. And I know that there is a problem of the instability with when you factor other things in, but these actually are coming from the way that we are trying to explain the behavior. And that's like, we know that subjects will have different impressions from different types of content and so on. This, at least when I look at it right now, seems that, you know, the cases where what I described would be basically taken into account. So you say, oh, if the subject hit the mark, no matter how reliable they are, I'm going to take it as a reliable score. And that's a little, that doesn't sit well with me that much, but it's not saying that, you know, the move towards the non-parametric is not the right thing. And I'm mostly trying to think like how we could potentially regularize or somehow protect ourselves from overly fitting to the data, even in the cases where people are clearly spamming.
Exactly. I think we are aligned on this perspective, because the question still remains how to protect yourself regarding overfitting, like, and stuff like this. But also regarding the philosophy behind Surya, it's perfect for many applications. For instance, in these applications here, a spammer annotator, it's super hard to beat Surya because this is exactly the setting for which Surya is taught, right? Like, you have a spammer annotator, you want your system to be as robust as possible to that kind of annotator. And that is exactly why in a setting like this, and this might be a setting that is more close to what you might observe in a subjective in a crowdsourcing experiment where people get in, they just accept, there is no control, and so they might just give whatever they like. So for me, it's there is no wrong assumption here. Also assuming that we just want to be to be robust to people that in most of the time just give a spam rating. It's a way, it's a perspective that is totally meaningful, and it has its own application. And indeed, all my works here are inspired by Surreal. So by the work behind Surreal, it's an approach that obviously have really, inspired me for all of the other things that I have been doing. And yeah, definitely. Then I agree with you that the question is how to, smartly transform parametric approaches into a approach that can give more information without overfitting the data.
Okay, thanks. Well, sure. We still have one presentation in JEG hybrid. We are 10 minutes past the break time. I'm not sure what the Chase would like us to do.
I would suggest taking a break for 15 minutes and then resume with that talk. We have one cancellation at the end of the second session. So hopefully the timing will out.
Okay, next one
Yeah.
should be shorter.
So
yeah, I was about to suggest the same thing. I think that would be good at this point. Maybe we can reconvene at 16:45 Central European time, or 45 after the hour. I will stop the recording now.